Rn is equal to n square h square epsilon divided by pi m z square, which is in the form of general form. We have already derived this expression. Okay. So for hydrogen atom, the atomic number is 1. Okay. So therefore we will be getting Rn is equal to n square h square epsilon naught divided by pi m e square in place of z. Z means atomic number. So for hydrogen we are having z is equal to 1. So therefore our expression becomes Rn is equal to n square h square epsilon naught divided by pi m e square. And you should remember these two important notes that for first orbit of hydrogen atom, as we know that the atomic number is z is equal to 1. We are saying that first orbit, then our orbit number will be n is equal to 1. One thing you should remember, dear students, that always this n indicates the orbit number. N indicates the orbit number. So we are saying that here for first orbit. If it was second orbit, then in place of 1, you would have taken 2. Okay. So here for first orbit of hydrogen atom, Z hydrogen atom we are saying. So for that Z is equal to 1, N is equal to 1. So therefore, if I substitute this Z is equal to 1 and N equal to 1 in this above expression, 1 square becomes 1. H square epsilon naught divided by pi m square. So this is the required expression we got for the first orbit. For the first orbit, R1 is equal to h square epsilon divided by pi m e square. So if I substitute the epsilon value, that is the relative probability value, and the Planck's constant value, mass of the electron, charge of the electron, pi value, if I substitute all these values, then I will be getting 0.53 angstrom, which is the required radius for the first orbit. Okay, so this radius is called as, this R1 is equal to 0.53 angstrom is called as Bohr's radius. It is called as Bohr's radius. For first orbit of an hydrogen atom, whatever the value we are getting, that radius value, that radius is called as, it is Bohr's radius. Okay. Now the second point is that, as from this expression, is all terms h square epsilon naught pi m e square, all these are all the constant values. They are the constants. Okay. Hence, the radius, the for the electron for the nth radius is always directly proportional to the square of the orbit number. Rn is always directly proportional to the square of the orbit number. Okay. That means as the orbit number increases, the radius also increases. In simple way, you should remember this one. Okay. So I have taken these values here. For R1 it is 1. R2 second orbit 2 square, 3 square. So our radius will be R1 is equal to 1, R2 is equal to 4, and R3 is equal to 3. So R is to that is in the form of ratios I have written here. In ratios it will become R1 is to 2, R2 is to 3 is equal to 1 is to 4, 4 is to 9. Okay. So this shows that the electrons in the orbits, they are not equally spaced. They are not equally spaced. Say for example, this is the nucleus. This is the first orbit, second orbit, third orbit, fourth orbit, that is first, second, third, fourth. So from nucleus to this first orbit, the radius is 1. That is how much radius? 0.53 angstrom. If I substitute the two value here, then 2 square, 2 2s are 4, 4 h square, substituting the Planck's constant value, absolute value, then I'll get some value. Again the radius decreases. This is R1, R2, next R3, next R4. So these all radius are not equally spaced. Okay, they are not equally spaced because we are getting the square value here. N square. Every time it is becoming twice here. यहाँ पे जितना है समझो फॉर एग्जांपल यहाँ से रेडियस है मानो हमारा 2 फॉर एग्जांपल से 2 सेंटीमीटर, बट यहाँ से जब हम देखेंगे तो ये 4 सेंटीमीटर होगा। नेक्स्ट इससे फिर यहाँ पे फिर ज्यादा स्क्वायर बनते जाएगा वो, फिर यहाँ से 4 स्क्वायर होगा वो तो 16 बन जाएगा, नेक्स्ट 16 स्क्वायर ऐसा। सो आई एम जस्ट एज एन एग्जांपल. So here that means Rn is directly proportional to the square of the nth orbit. So this shows that electron orbits, these are the electron orbits, they are not equally spaced. यहाँ पे जितना है ये इतना है, फिर आगे इतना है, फिर आगे इतना है. They are not equally spaced. So these two important notes you should remember always. Okay. So that is, we have taken this just for an example. First orbit we are seeing. Okay. If I take 2 here, then the value of this radius changes here. Okay. So you can try this. You can try to solve this. Just to try to solve this this second radius, third radius, and fourth radius. You will get the values. Different values you will get. Okay. Just to take it that as a homework. Okay, just go on substituting the values. Already I have taken here n is equal to 1. You can take 2, 3, 4 like this. Okay. So next we are going to continue the next topic. It is we are going to find out there is expression for the for velocity. Okay. That will derive. Okay. So next we are going to derive an expression for orbital velocity of electron in the nth orbit. In nth orbit, what will be the orbital velocity of the electron? That is what we are going to derive. Okay. As in the last class, we have derived an expression for radius of the electron in the nth orbit. We have derived. There I have considered an electron, okay, having a mass m, which is going to revolve around the nucleus. The nucleus is having a charge that is Ze, and the charge of the electron will be that is negative always. Okay, here also I am considering an electron in an orbit, an electron in an orbit which is revolving around the nucleus, having a charge that is plus Ze. Okay, and for this we are having a negative charge, and the radius is r, so which is revolving around the nucleus in a circular path. Okay, so the mass of this electron is m is the mass of the electron, right? So here the electron which is revolving around the nucleus, here the electrostatic force between the electron and the nucleus is given by F is equal to 1 by 4 pi epsilon naught, that is Ze into E divided by R square. That is square of the distance between the, that is nucleus and the electron here. So it becomes 1 by F, that is 1 by epsilon naught Ze square divided by R square. Let's take this as equation number 1. Okay. So this provides, and this provides the centripetal force which is required for the electron to revolve around the nucleus. So that centripetal force becomes, will be Fc is equal to mv square divided by r, that Let's take this as equation number 2. Okay. Now compare these 1 and 2. Comparing 1 and 2. Since here Fe is equal to Fc. Okay. Electrostatic force between the electron and the nucleus is equal to the centripetal force which is required from the electron to revolve around the nucleus is always equal here. Since both are equal, hence we are writing this as 1 by 4 pi epsilon naught Z square divided by R square equal to mv square divided by R. As this R one will get cancels, so I'm just again rearranging this one. mv square is equal to 1 by 4 pi epsilon naught Z square divided by R. As one R remains here, so I'm writing here mv square R is equal to 1 by 4 pi epsilon naught Z square. Now take this as equation number 3. Okay, it's very simple. Now, as we know that according to the Bohr's second postulate, the angular momentum of the electron is given by L equal to NH by 2 pi. So L means here angular momentum. L means angular momentum. L means angular momentum. So I can write this as L means mvr is equal to the product of the mass of the electron and the velocity and the radius. It is mvr nh by 2 pi. Take this as equation number 4. Okay. Now let us divide these three equations. Dividing 3 and 4. Okay. So mv square r whole divided by mvr equal to 1 by 4 pi epsilon naught z square whole divided by nh by 2 pi. Here will get cancels, r will get cancelled, 3 and 1 will get cancelled. So I will be getting v is equal to 1 by 4 pi epsilon naught z square into, as it goes to the numerator, it is 2 pi divided by nh. Okay, here pi will get cancelled, 2 ones are 2 twos are, so it becomes v is equal to 1 by, there is ze square divided by 2nh epsilon naught. Okay, 2nh epsilon. So which is required expression for the orbital velocity of the electron in the nth orbit. So which is a required expression for the orbital velocity of the electron in the nth orbit. Okay, so here dear students. So here n indicates the number of orbits. So here n, it might be a 1, 2, 3 dash. Okay, 1, 2, 3 dash. Here z is indicating the atomic number. Here z is indicating the atomic number. For a hydrogen atom, z is equal to 1. So this expression becomes, I am writing here, v is equal to E square divided by 2nh epsilon naught. Okay, this expression is for hydrogen atom, where I have taken here z is equal to 1. So I have substituted the value of z here 1. So I got V is equal to E square divided by 2 minus epsilon. So one thing you should remember, dear students, here that from this expression we got to know that, so I am writing here, V is inversely proportional to N. Orbital velocity is inversely proportional to the orbit number. Okay. As the orbit number increases, the orbital velocity of the electron decreases. Okay. If the orbit number is less, then the orbital velocity will be more. Both are inversely proportional to each other. Okay. So this is a very important expression, students. Okay. So for today's homework, you practice this expression for at least 10 times. 10 times you have to practice at your home. Okay. And this is a very important expression, and you will be having numericals on this expression also. Okay. So today we will stop here. In the next class, we will continue with the next topic. Thank you.